I would love to welcome onto the stage from Arm, the Chief Marketing Officer, Ami Badani, who was at a company for 4 years called NVIDIA. From Silo AI, which is a huge team of big-brained PhDs connected with universities like Aalto University and now part of AMD, Peter Sarlin. And then from Vattenfall, a 100-year-old company, Sweden-based, really understands how to become more sustainable in energy. It's one of their big priorities. Anna Borg, please welcome the panelists out. Hello. First of all, let's try and understand the scale of the problem, because I'm a bit confused how urgent this worry is. Should we be panicking as we're both trying to move towards net zero and process more data? If you look at the International Energy Agency's reports, it had a report in 2024. It said that data centers globally only use 1 or 2% of all electricity. And maybe crypto is about a quarter of that at the moment. And yet, a country like Ireland, which has an awful lot of data centers working for the big tech companies, 17% of the country's electricity is consumed in data centers. And there's growing concern about how to solve that, because it's not just energy, it's also water use to cool a lot of these servers. So just give us, Peter, a sense from where you're standing, because you are working with a whole bunch of experts. Silo calls itself the largest private AI lab in Europe. How worried should we be?
Let's start off with sort of defining what we're actually looking at, because I mean, Silo has been, and I've been working with AI for the past 10 plus years, and AI is a wide range of different technologies. Of course, now we're talking about general purpose AI models, and models that are growing larger and larger and larger. I do think it's still worth noting that a large part of the use cases out there are also other use cases, are also other machine learning technologies that are creating value. Ultimately, I think we should really focus on the value that is being created. But then when it comes to sort of how concerned and what should we do about this concern, I mean, innovation we've seen in the past few months or weeks, everything ranging from DeepSeek publishing new models to Mistral and others publishing new models. You know, I think there will be innovation. We will find efficiency both in terms of models and also in terms of hardware. AMD.
But how bad is it now? How serious is the challenge of having to find very quickly new ways to operate the whole data center?
No, I mean, you can I mean, how bad it is, eventually, I personally, as I was saying, believe that we will continue to see innovation on hardware side and also on the model side, and eventually the sort of cost per value will go down. And that ultimately is sort of the most important element in why we are utilizing energy. And then I think, you know, Anna and others will have solutions to how we move towards green. And a lot of the, I mean, all of the models that Silo has built in terms of foundation models, they've built on 100% hydro, which is even heating the neighboring cities, so with a net positive impact.
Okay, I'm still trying to understand where we are now. Ami, Arm is, you know, the team that works on optimizing the architecture of chips. other people can build the chips, but you're working super hard on making them ever more energy efficient.
Right.
Are we in a good place? Is there a big reason to think we're in trouble?
So I think we got to look at so I'm an AI optimist by nature, and I believe that only good things will come. We're still at the starting point of AI. So I think if we want to get to AGI, everyone has their own definition of what AGI looks like, but if we want to get to where we really want scale with AI, I think we need to solve the energy problem. So today, it doesn't really look like we're in a horrible position, but to the scaling laws of where we want to scale, if we don't solve the energy problem, we're going to be in a tremendously bad position over time.
And how can we do that?
I think there are different ways to think about it. You got to look at the energy efficient compute, and that's really where ARM plays. You got to look at the software optimizations that Peter was talking about. You got to look at the cooling that comes into cooling the data center racks. And if you look at kind of each level of the stack, probably 50 to 70% is what I like to say of the energy consumption today is in the compute chips plus the cooling of those data center racks. So we need to solve really looking at solutions for those things in order to scale where we need to get to.
Do you think the hardware is the way we're going to solve this, or is it new?
No, I think you need optimizations everywhere. It's not only a hardware problem. It's not only a software problem. It's not only an energy problem in terms of looking at renewables. It's sort of across the entire spectrum.
So energy is what Vattenfall does, and you're thinking a lot about moving towards renewables and defossilizing. You're both a source of the fuel that powers the AI revolution, but you're also working with a lot of big companies, yourself included, that are using AI to optimize your processes. How, in Vattenfall, are you thinking about chip versus energy?
I think that you really need to look at the entire value chain, and we already heard several examples of that. You are right, we are looking at decarbonizing, and our vision is that we will enable fossil freedom. And for us, that means that we have, over the last 10 years, dramatically retailored our own portfolio. So we basically only have low-emitting energy production today. And I am not too concerned, because I think you cannot assume that technology will look the way it does today and then just stack it on top of each other and say that's the future. There will be a lot of development in this value chain. We already see examples of chips that are, much more efficient than they used to be, and where you need less power to sort of do the same kind of calculations or output. And I think we will see more of that, but we will need to be looking at the development cross. And what we are doing is that we are powering quite a lot of data centers around in Europe. We have a European business. And for example, we can match and make sure that they get the fossil-free electricity delivery 24/7. And we do that by optimizing, for example, between wind and large-scale hydropower. So we provide them the wind when it's windy, and we provide the large-scale hydropower when it's not windy. And of course, there are other technologies which you can do the same thing with. And we also work with actually using the excess heat, just as Peter described in another project, into a local district heating grid in a city, so that you can actually get the output from the data center as well to good use. So I'm not very concerned. I think there are a lot of technologies and business opportunities here. But I also think that AI will really contribute to the energy industry and improving our industry. And we see many signs of that already, all the way from optimizing grids to optimizing our fuel strategies or our maintenance strategies, but also creating new business models for us.
And optimizing the grid, how big an opportunity is this? How inefficient is the energy grid at the moment in Europe?
No, I think that it's probably quite efficient given what it looks like. So it needs to some extent to be built out to cope with the increased both demand and supply. But of course, AI can provide you can do much more of sort of live runs with data in an AI model than you can do in real life. So you can speed up the development and the learning quite a lot. And maybe to draw a parallel to what we are doing in our business, we knew, for example, and that is not related to the grid, although the grid is involved as well, but we knew we had to be much better at forecasting sun radiation, to forecast how much production there would be from solar power, because we see a lot of solar cells on roofs these days. And in the Netherlands, for example, the rollout of solar panels has been so big that it actually has an impact on the intraday traded market in energy. So what we do is we use AI to forecast sun radiation, not on the city or on roofs, but on that specific city, in that house, in that street, in the next 15 minutes. And if we aggregate that data, we can actually trade on the intraday market. And we knew how to do that, we just couldn't do it fast enough. And still there is not time to communicate with the trader within those 15 minutes, so we communicate with an algorithm that do the trading. And then we just have someone sort of surveilling that. And that is, of course, optimizing the total energy system and the usage of the energy system intraday. And that's something we can do thanks to AI.
But it also means that big companies like Microsoft are buying former nuclear power plants to switch them back on. So there is clearly a perception among the people powering use of AI that we're going to need a whole load more energy. And we're in a moment now where AI agents are something everybody's talking about and starting to use, but there's clearly a shift, a platform shift happening in every sort of organization. Peter, what are you seeing in your customers' behavior that's telling you where the overall direction is going? How are they thinking not just about the demand for energy, but the way they're thinking about how they're sourcing energy?
So, as Silo, we're obviously looking at the ones building models. And then they can be consumers of energy, but eventually compute in various forms. But I mean, I think as was alluded to, I think the opportunities are vast in terms of what type of applications they're going after. The developments that have happened and continue to happen are actually pushing down the requirement of compute for many use cases. And that's, of course, what we saw with DeepSeek, and that's what we're seeing with with model distillation, with many types of sort of new applications or new uses of existing models. But then what I'm seeing and where I'm seeing opportunities, all of those other use cases. I think these general purpose models will continue to be built. Some of them will continue to become larger. Many of them will actually become smaller. But then we will open up new opportunities in everything ranging from life sciences to material sciences to robotics to autonomous vehicles and so forth. And I think that's really sort of if we think about where AI will create value, well, we will eventually consume compute and eventually then consume energy. That's where it will happen.
But it's unquestionable that the acceleration in the abilities of the large language models is consuming more and more energy. GPT-3 models typically, from what I can tell, took about 1,300 megawatts per hour. GPT-4, about 50 times that. And as you can see by those exponential graphs behind Jensen Huang of his chips becoming, 1,000 times as powerful as the chips from 8 years ago, that's only going to grow. Can we solve that? What are the innovations?
I guess the question is, what should we solve? I mean, I think I would agree entirely that there is a problem to be solved with energy. I mean, eventually that energy source and a source that is stable enough and aligned with what you need for a data center, those we need to find, and we need to solve that. Can we solve it? I personally believe that we will, and if we look at the developments that are happening in AI, and I mean, still, even though you're referring to GPT-3 to GPT-4, I mean, it's a general purpose model. Then if you look at the vast amounts of AI applications out there, you don't always need a general purpose model. For many of them, you actually can do very well with a small distilled model. And I think
DeepSeek showed. And it also showed that open source has great potential. Is open source the friend of the decarbonizers?
I think it certainly is. And I mean, I would treat open source as a kind of digital infrastructure driving sovereignty in every country out there, which in practice just implies that there exists performant models that are aligned with language, with value, with culture, and so forth. But it also implies that any business in that specific region, be it in European countries where we have contributed to models performant on European languages or some other country, then the businesses there can tap into existing models and build on them. And that implies that not everyone should build models from scratch, but you actually utilize, be it DeepSeek or Llama models or some of the other open source models, and in many cases actually distill them to be performant for specific different tasks.
Ami, I'm going to ask you to give us a very short masterclass in how we can design more efficient chips, how we can think not just about the chip, but about the wider ecosystem in which they're operating. Yeah. Whether we have them more on our devices doing the work rather than in the cloud powered by data centers. From your knowledge, formerly NVIDIA, now Arm, what can we do and what does it mean in practical terms?
Yeah, I think if you look at kind of the over time, what you've seen is most of the hyperscalers, you take other Microsoft, Google, Amazon, any of these hyperscalers, they've been really focused in the past mainly on the application level because most of the chips have been, for a large part, commoditized and you could just kind of abstract away the complexity in the chips. I think what you're seeing more and more is that you need differentiation all the way up and down the stack, and you need to have a vertically integrated system. So what we're seeing now is a lot of the folks want to create vertical specification and differentiation, and you need to get down to the silicon level. And once you get down to the silicon level, you can get to that power efficiency that you want. And so for ARM, one of the things, power efficiency has been in our DNA. We sort of started back when you had the Apple Newton back in the 90s, and then the first application of where ARM really came to life was in mobile phones, which were all battery powered. And so our DNA has really been in power efficiency. And now it's coming to the data center more and more into the forefront because of AI. But specifically what you can do on the chip side is think about things around flexibility. What components can you put on the board, off the board, on the chip, off the chip? So it's really about flexibly providing a chip and a system. So it's not only at the chip level, but it's at the system level to really get the power efficiency gains. So for us, Microsoft, Google, Amazon, they're all of our customers. On average, we provide 40% plus power efficiency gains. We're also, with NVIDIA, we pair with their Grace Blackwell, which is sort of their next generation accelerator. And Grace is all designed around ARM, specifically for the power efficiency gains. But what I think is really going to happen, back to your earlier question around use cases, what we're really seeing is democratization of AI, specifically in coding, which will drive a lot of these innovative new use cases. I look at my own personal household, and I have a 13-year-old son who has now become a coder with zero coding experience because of all the information and because it's all the information that you're able to now create a model on your own. So I think just having all these coders that were not coders before, will drive a lot of that innovation to those new and interesting use cases, which you'll need just a lot more chips, more power-efficient chips to really drive that innovation forward.
And is there a Moore's law kind of trend happening in energy efficiency? I'm seeing some quite reassuring data points that, 2010 to 2018, use of global data centers up 500, 600%, but the energy increase was only about 6%. I think that's called Koomey's law. But are you seeing this wider trend that we can extrapolate?
In terms of Moore's law, I think you'll just have more compute. So by essence, you'll be able to, I don't think Moore's law is going to slow us down. There's so much innovation that needs to happen on the energy front that we haven't even started to really scratch the surface of. So if anything, I think it will just accelerate.
Okay. Leave us some optimism. Leave us something to be hopeful for. Anna, first of all, should we be anxious on a scale between 0, not at all, and 10, it's crazy, we've got to do something now? But also a concrete takeaway for the people here whose organizations are consuming ever more data, and energy is kind of expensive anyway, and cloud pricing is not getting that much cheaper. What should they be doing? So first of all, a mood, 0 to 10, and then an action point.
Well, my mood is actually not on an anxiety scale, it's on a focus scale. And on the focus scale, I'm a 10, because I think we need a lot of focus on this. But it's also definitely solvable. And I think, yes, there will be a more need for energy in order to feed computing and AI, but there will also be more energy needed in order to transform a lot of other industries to also decarbonize. So I think if you zoom out a bit, this is not the only need we're going to cater for. We're going to cater for a much larger need. And that, of course, makes the challenge one of magnitude. But we have the technologies needed to solve this. We have the knowledge. The capital is willing to move in, but we need to increase the pace. So I think the direction is very clear, but the pace is not. And this increase in electricity generation also needs to be with emissions that have a climate footprint that is acceptable from a sustainability point of view. And we heard that in the discussion just before we entered the stage. And that brings me back to your example around nuclear and the companies sort of joining forces. And I think we're going to need all the technologies that we can get our hands on in order to meet this demand with an acceptable climate impact, because climate change is real, it's not going anywhere regarding who is negotiating with whom. We're all going to have to solve for that. And the only way to be competitive long term is to make sure that you have a sustainability footprint that is acceptable. And therefore, it's our sort of responsibility and business model to do that. And it's also our business to provide that energy to the companies that we see here.
Let's hope fusion advances. 30 seconds, Peter. Anxiety scale 0 to 10 and concrete things somebody here can go back and do.
I'm an optimist, and I believe that AI, the sort of cost to value ratio will go down, and we will create significant value with AI. And then I believe that the technological innovation that is happening is going to solve the problem that we have. The number is 10.
Okay. You get the last word, Ami.
Yeah, I mean, I'm a 10. I believe that AI will be a force of good for us, so I'm actually not worried. I think we'll solve a lot of these problems. And I'm glad that we're, as a kind of globally thinking about energy as a problem. And so now that we have sort of a microscope on the problem, I believe that we'll find solutions.
You have the ultimate Mobile World Congress panel of optimists who are not concerned about the energy consequences of the AI revolution. Thank you very much, Anna, Peter, and Ami.
Thank you.